part, which will be section 4, typical propeller installation and inspection. Just got on my page for that one. It should be there. There we go. Okay. Any questions before we start as well? Anybody got any immediate points you want to make make a note of them at least anyway, and we'll try and get through them this afternoon if possible. At the moment, this morning, just remember to switch your microphones off, guys, until the chat. Juice there, I heard that going.
हुन्छ अल टाइम त लाग्छ यिनीहरु त गरे टाइम लाग्छ 3-4 वटै छ सर आको त टाइम त लाग्छ यिनीहरु ए हुन्छ ए हस् हुन्छ सर नमस्ते
Yeah, thank you very much.
Oh, sorry.
Okay, right guys, let's move on. Excuse me. Okay, so section 4, typical propeller installation and inspection. And we'll just get on as quick as we can to get more time for, oh, don't want that one, I apologise, for revision. So I've got my pen going. Yeah. There we go, ready to go. Okay, right, so turn propeller blades manually. Yeah, usually required before removing propeller, we need to actually rotate the blades into a feather position. If it's not shut down automatically, and sometimes we need to move them into a different position to actually access the centrifugal latches. So we can disengage them and allows us to manually remove the propeller. Okay, so we need to make sure they are in the feather position. And back home here in Scotland, we put the blades into the fine position, lock them in position. So the students have to actually physically put them into the feather position just for a bit of practice. But normally you wouldn't leave them like that because that leaves a lot of tension on the spring. It's just not ideal, but again, it's just a training environment, so actually get practice of moving blades if required. Okay, and also allows us to fit the adapter to remove the propeller assembly. But normally, engine shut down, it's a single acting one. The blade will go into the feather position because of the spring. Now, you're going to remove your blades in a manual position. You must obviously follow safety and follow the procedure in the maintenance manual. Otherwise, you can damage the actual blades and potentially damage yourself because the spring action there will move these blades very, very quickly, and you need at least 2 to 3 people to do them anyway. So if it's not prepared to be serviced, it's dismantled or put in storage, and before removal, the blades are placed into the feather position and usually on shutdown, which it would do automatically. But if not, if everyone's working okay, you make sure they are in the feather position. If the blades are manually, then propeller blade bats or paddles is what we call them, are sometimes used. I'll show you a diagram shortly. Preferred number of operators to move the blades is 1 per blade. If you can't do that, at least 2 minimum. Sometimes the access isn't brilliant, but ideally 3, because that puts a nice even pressure on each propeller, especially if it's 3 or more blades. Okay. That's the sort of thing we're on about. Now you can see there's a wooden paddle or plastic paddle or bat that goes over the blade, over the strongest point of the blade as well. Don't put it on the tip. We usually have a marked top. This photograph here is actually one of our aircraft at the hangar up here in Scone, Scotland, and these are locally made wooden paddles. You can see the profile of the blade, and they fit roughly about halfway down to the strongest point of the blade, and then we can twist the blade to the feather position. In this case, as this one is now in the fine position, as soon as we remove the latches, that spring will try and move those blades straight away. So when we take the pressure, another person will remove the latches. You've got to hold those paddles, otherwise they will spring very, very quickly. And if you have a face height, it'll end in tears. So again, make sure everybody's got the pressure first, nice and steadily. They're quite long bats, so they will nice and steadily release the pressure, and everything will be okay. Sometimes you can find it, especially in train environments, sometimes the blades stick, so we have to let them ease off a little bit quicker. But again, practice and safety first as always, and always follow the manual. Spline shaft, variable pitch propeller, check your documentation for correct number, propeller engine combination. Make sure you're fitting the right one back to the same position, because you might have removed both engines, you might have removed both propeller assemblies, but make sure you put them back to the same position, unless obviously you're replacing it. Removal protection blanks, etc. from storage. Inspect the propeller prior to fitting it, obviously, just in case somebody's knocked it off the shelving or wherever. Lubricate is specified, again that will tell you in the manual which type of lubricant to use, usually some engine oil normally. Inspect and fit the electrical bush gear housing to the engine reduction gear housing. Inspect your spinner, check for assembly, squareness, electrically connected de-icing ring to the slip ring issue, and fit an approved cesspool sling to propeller, lightly lubricate the spline. Again, usually normally a bit of a standard engine oil, but again, check your manual for any more specific lubricant. A thread protector, it's just a sleeve that before you tighten everything up, it slides it over the spline, and that way it stops damaging the propeller assembly initially. Then once you've got it roughly fitted on, you take the sleeve out, and then you'll put your cones in, etc. Okay. Always put new seals, never use the old seals again, and lubricate very appropriately, and carry what's called a bluing check on the front and rear cones, and we'll mention that just shortly. So the cones again, remember earlier on, your front one, again, make sure you've got seal numbers because they're split. Front ones are made of steel normally, and the rear ones are brass. And we'll do what's called a bluing check on them in a minute. So the bluing check, we get engineer's blue. It's like an ink, it goes on wet, and it allows the checking what is touching, surfaces are touching each other. So the more blue we see when we take it off, the more surface is being touched by the opposite area. If there's not a lot there, then we'll see what's happening. So lightly smear engineer's blue to the front and rear hub seating surfaces. Check the rear cone is in position, and then install a propeller in the shaft. Remember using your thread protector, and hand tighten the front cone assembly retainer nut. Okay. Rotate the propeller at least once. Remove the hub nut again, and the front cone assembly. Fit your thread protector. Take the propeller back off, and then you check the surface contact of the cones and their seating surfaces. Okay. Now the contact area must be at least 80% of the whole surface. Okay. So basically, if you turn it and no bluing comes off, then it's not touching properly. So it should be at least 8% of the bluing has come off. All right. So make a note of this one, please, guys. Highlight in the book. So you apply the bluing compound ink, rotate it, and it should come off at least 80%. If it's less than 80%, we need to adjust the cone positions. Minor high spots may be removed by light honing, so a very fine polishing to improve contact area. Honing, like we do in piston engines, is an abrasive machining process, a precision surface on a metal workpiece by scrubbing abrasive stone against it in a controlled path. We do the same sort of thing in fibre optics as well. Honing is primarily used to improve the geometric form, in other words, making the surface a lot smoother, and indeed possibly changing the angle. Once you're happy with it, you take all the excess blue off from the cone seating surfaces, and you'll check it again. And you'll keep doing that until you're happy you're getting the correct amount of at least 80% contact. Okay. So again, looking diagram, there's your rear cone, okay, and the front spline cone, and all you're doing is checking that the flange and the assembly is mating together properly. So once you're happy with that, fit the propeller, let it lubricate the hub splines again, threads and specified lubricant. Cone faces normally left dry. We don't put lubricant on them, we put them on dry. And that prevents the propeller loosening as oil is squeezed out. If we make them all wet already, then there's a good chance they're going to try and pop back out. They won't actually sit properly. So you fit a propeller back on the engine shaft, remove the thread protector again, fit your front cone assembly and your hub retain nut, hand tighten the hub nut again, and then torque load using a torque wrench, correct one, to the stated figure in your book. And usually that'll probably a duplicate check as well, where you'll lock it, and because it's quite essential, that doesn't come off, you might get a supervisor to check that using a duplicate check. You might have to sign for that as well. Fit a locking device and then remove the sling that holds the assembly on. Never remove the lifting sling until you've fully tightened your assembly onto the propeller. Okay, now it could be a hub nut, it could be a flange type, but never remove any lifting equipment until you're 100%, you've got everything in place. Bit embarrassing if it falls off when you've taken the sling off. Fit your inner outer oil tubes, again, torque, tighten, lock. Inner oil tube, usually left-hand thread on the outer right-hand thread. Okay, so just be aware of the thread, so left and right-handed. Again, you probably noticed that as you took it off. Propeller blades to the feather position if it isn't done so already. Okay. Exchange mechanism and lock. Prime and bleed the cylinder as required. Fit your spinner, so your actual cap on there. Again, turn the blades to full extent to check there's nothing touching, okay, before you start the engine, before you do leak checks, etc. Carry out a track and radius check. So yeah, you'll spin the propeller. Remember, do your tracking. Remember, it was 1/4 of an inch of surface area. Spin the propeller. If it's a twin or a triple or whatever, check your tracking. And if it's not quite right, just double check the torque setting on the nut as well. And then obviously, once you're happy it's physically all connected correctly, you've oiled it all up, it's all ready to go, then we'll carry out a ground run and to check correct function of the propeller. Start it up, let the engine warm up as well, and stop the engine and check for oil leaks. If satisfactory, then you will restart the engine. So you're just letting the engine warm up initially, not doing any functional checks, you're letting the engine warm up, but getting the oil flowing around the system. Stop it, check for leaks, and then start it up again, and then we can carry out the functionals. Exercise the propeller. That doesn't mean doing star jumps or press ups or sit ups. What we're doing is we're going to move the pitch of the propeller from fine to coarse to off the fair, sorry, and back again a few times. And what you're doing is you're warming the oil up in that system, and you're also getting rid of the air that's potentially in the system. When you disconnect an oil pipe, undoubtedly there's going to be some air going there. And like hydraulics, if you have air in your oil system, especially in hydraulics, it won't work properly. So by exercising the piston, it's a self-bleeding system. In other words, the more you exercise it, it will eventually get rid of the air out of the system. And you do that as many times until you feel that it is operating correctly. If you're doing that and it's still not operating correctly, you might have a leak somewhere. Again, hopefully that'll be noticeable, and you can shut the engine down and go and sort it out, hopefully. Then you do your constant speed check, your power output, feathering, unfeathering checks, de-icing obviously, and your synchronization and synchrophasing. And while you're doing all this, obviously, at any point during an engine ground run, you find a bit of vibration, take a note of where it is, and then shut the engine down and then try and figure out what's going on. Again, follow your manual as required. After your ground run, check for oil leaks and issue a certificate of release to service card, giving you signature, date, license number, and make all relevant logbook entries. Okay. Again, initially that'll probably be your supervisor until you're authorised to do that as well. Okay. Once you sign the CRS, you're saying that engine, that propeller, is fit to fly. So do not sign that until you are 100% done. You've done everything, and you're also signing once you've done every job on a job card that you've put all your tools away. Some companies will have a separate stamp, possibly, to say 100% tool check carried out. Bit embarrassing when an aircraft goes flying and you can't find one of your tools. Okay, so make sure you do 100% tool check. The rear cone bottoming. Now, when you've checked everything and you've done ground and all that sort of thing, we can get points. So when we are fitting assembly, that the rear cone bottoming, in other words, occurs when the apex or point of the rear cone contacts with the land on the rear seat of the actual hub of the propeller assembly before the hub becomes seated on the cone. In other words, the cone's too big. Okay, although it's the correct cone, just because it's a slight difference, it could be a brand new one, we need to just machine it to make it fit properly. And that's represented here. So you can just see here, there's the propeller hub. Okay, so this will be the shaft of the engine here. There's an engine there. There's the cone. Okay, but it's just touching the hub. And you can see here, there's a bit of a gap. So if there's a bit of a gap, unfortunately, there's going to be a bit of vibration. So we need to adjust the cone a little bit, just so it mates properly with the propeller shaft. And sometimes you find that with brand new cones, just needs a little bit of machining just to make it fit perfectly. Now, you can do this by removing up to 1/16 of an inch from the apex of the cone using good old sandpaper and a surface plate, so a genuine flat place as surface area, and using sandpaper. Rear cone bottoming occurs when the tip of the rear cone contacts the land, as said, before it gets the seat on the cone. So removal of the specified amount of material from the cone's apex corrects the problem by using a surface plate and a fine abrasive cloth, and we lap it on the apex of the rear of the cone. So basically, there's your cone, and all you do, you've got a nice little surface plate there, and some fine, not a coarse abrasive, it'd be a fine, because you're only taking a 1/16 of an inch off, which is not a lot, and you'll only do a little bit of time, check it until you're happy. So let's pretend this part here is the new cone. So you can see the angle there, nice and pointy, but we found out that it's touching the land of the assembly too quick. So what we're going to do is we're going to take a bit off of this bit, up to 1/16 of an inch. So just sandpaper, just go round and round and round, or a figure of 8, whichever one you want to do it, and check it, take about 1/16 of an inch off, so we reduce the size. So the apex, which was in line with this dotted line here now, is now the apex is slightly up here. In other words, we've just shortened the rear cone a little bit. Not a lot, only about 1/16 of an inch maximum, because they should pretty much fit, but again, we allow for a little bit of wear and tear. The front cone, well, the front cone bottom curves from the apex. The front cone, again, bottoms on the propeller shaft spines before, again, it has a chance to seat on the hub. Now, front cone bottoming is indicated by either the hub being loose, so you can actually feel a little bit of looseness, even though you've tightened the nut up, after the chain nut has been taught, or when there is no transfer of engineer's blue to the front hub seat. So you've tightened it up, you spun it, you took it off, you checked the blue, and you went, oh, there's still blue on there. There should be at least 80% taken off. Well, that means it's not touching properly. Okay, so we need to adjust that one. Now the front cone bottom is corrected, so it's worth making a note of this, by using a spacer or shims no more than 1/8 of an inch, so twice the thickness of sanding off the rear one. So the front cone, we can use shims to increase the space of the thickness behind the rear cone. So once you're happy the rear cone is fitting and making the flange, we can actually push that whole assembly, so washers behind the cone, which will push against the assembly, which will push it closer to the front cone, and that'll take up the slack. Okay, so we're not physically altering the front cone, we're just moving everything from the rear to push up to the front cone. So as it says there, it moves the hub forward, and that enables the hub to properly seat on the front cone. Okay, so there we go. So there's the hub. Okay, just sort of taken away. There's the shaft. There's the end of the spine. You can see the front cone, and there's the yellow be the retaining nut, which is pushing against the end of the spine, which is great, but it's not pushing against the hub. So back here, you'll have the assembly, and behind that, you'll have the rear cone, which we've adjusted to match the assembly. And then by pushing or putting shims or washers behind the back cone, that'll push everything forward, which will take up this gap here. Okay. So for adjusting the rear cone, we actually physically sand it down a little bit. For adjusting the front cone, we just push everything from the back, okay, by adding some shims up to about 1/8 of an inch. So remember those numbers: 1/16 of an inch maximum off the rear cone, or by adding shims or washers up to about 1/8 of an inch to adjust the front cone. Okay, and I can guarantee there'll be a question on one of those. Again, we don't get to see the questions, but usually one of those, what's the front cone adjustment or the rear cone adjustment, they might ask you a question on that, so it's worth making a note of that. Okay, quite straightforward, nothing too difficult. We take up the space, although the part numbers should be identical, a little bit of wear and tear, older splines, new splines, new hub assemblies, old hub assemblies. We've just got to take a little bit of play up there, possibly. But again, 1/8 of an inch, 1/16 of an inch, it's not a lot, not a lot at all. And there we go, so it prevents a good hub seat. Now that's it for a spline connection. For a flange connection, nice and straightforward. Again, check propeller model number, documentation, correct propeller, etc. for installation prior to fit it, make sure it's the right one. Clean everything before you fit the propeller and the shaft flange. And again, make sure the holes are okay, because it might be the same engine you put back on. Check for transit damage. Yeah, it happens. We get brand new assemblies, components that come in a box. The box might have been dropped, and poor handling by somebody, unfortunately, it can damage it. We have had that before on various types of aircraft. So don't just assume it's in a box. Take it out, go and fit it. It could potentially be damaged. Hopefully not. So examine the flange for cracks, thread damage. Rotate the crankshaft in DOR, direction of rotation, until impulse clicks. It only happens on piston engines. What happens when you spin the propeller? Now do this slowly and make sure power is off. There is no power, because you can get ignition, unfortunately, even when there's no power, because it could be residual fuel in the pistons. Okay, normally you would drain these off as follow your safety procedures, but if you spin the propeller fast enough and there is a residual amount of fuel in a piston engine, you can get what's called a dieseling effect, where it will spontaneously combust. It doesn't need a spark. Ignition source, it can actually go bang. Okay, so if you were to spin that fast enough, so nice and slowly, you'll hear the click, which is impulse coupling. I learned about that in Module 16. You might know about some of that already, so don't worry at the moment. Now be very careful on especially piston engines. Turboprop engines, it's fine. But piston engines, be very, very careful. Always keep your face away from pellet. They can kick around once or twice. Okay, so as long as you follow safe procedures, you'll be fine. But if in doubt, take the spark plugs out if need be. Okay, and that means there'll be no compression and no chance of sparking. But you will hear this click as you spin it around for every one revolution of the impulse couplings. Again, like everything else, if there's a seal fitted, put a new seal on it. Even if a brand new propeller comes with a seal, propeller assembly comes with a seal on it, take that seal off and put a new one on. You do not know how long that's been there. It might look okay, but just in case, always put a new seal on. Now looking, viewed from the front, install propeller at 5 past 7 position. In other words, you sort of, well, my camera, looking towards you, so it'll probably be that way for you guys. So looking at the clock scenario, looking at 5 past position, and that's for the piston engines, because you're going to rotate it as well. Fitting spinner, a rear diaphragm, spacer and dowel if required, apply jointing compound, but again, only put minimal amount of compound on there. Tighten nuts diagonally and torque load the specified torque. Like anything you work in an aircraft must be torque loaded. And carry it ground round as normal, as per your manual, checking vibration, establishing your reference for your propeller, check your data. Recheck, especially on anything that's bolted together, when it's warmed up, bedded in, you might have to do a retorque, make sure it's not loosened off, and then wire lock as well. Some places might just say torque and then wire lock at the same point. Some might say torque, run, torque, and then wire lock. Okay, just follow your manual. And once everyone's happy and you've done your test, use your warm-up procedures, etc. Again, issue a certificate of release to service, your license number, date, and usual logbook checks and entries. Okay. All right. So a typical flange position. There's the flange on the hub assembly. You see the bolts going there. Now the bolts will come in from the rear normally, screw into the flange, and then the back of the bolts, the heads of the bolts will probably wire locked. Certainly on the Jetstream they've got the wire lock on the back of the bolts. Smaller piston engines, there might be a bolt and a nut as well. Okay, so it might be a bolt nut, not actually screwed into there. The spinner, that's the final bit to put on, the aerodynamic cone. It goes in the front of the hub. Again, check the spinner and the bulkhead finish is damaged. Like anything, before you fit anything, you make sure it's fine, no damage or whatever. Coat the spinner seal, again with approved lubricant if it's got a seal, and install it into your dome assembly. Install the spinner, make sure the marks on the spinner and bulkhead are aligned. Now you might have marked that as you took it off. If it's a brand new one, there might be a dowel assembly that actually can only make sure it's on one way. So don't, if you have to force anything on, you've probably got it in the wrong position. Okay, so make sure you do have it in the right position. Then spinner, retain screw holes. Again, they're just small screws, so you will have to torque these up, but make sure you have the right torque setting. You don't want to snap the bolts in there. Again, okay, so in the Conway manual as normal. So there's a typical spinner. You can just see the small holes there. Okay, once it goes on, there'll be some retaining holes here, these small screws that will go in, and torque them up nice and gently. Okay. So you've done all that. You might have to install a CSU or a PCU. Again, installation quite straightforward. A new gasket. It's not a big component or mass component. Fitted on the mounting flange, and make sure the gear engages into the reduction gearbox. Let's say, and the main thing is ensure that the driven gear meshes with the drive gear, or you have a quill shaft. Okay, has everybody heard of a quill shaft before? Anybody not heard the term quill shaft? Yeah, you all know what a quill shaft is? Let's see, Saroj? Saroj, you there? You okay what a quill shaft is?
I don't know, sir.
You know what a quill shaft is?
I have no idea, sir.
Okay. Anybody else know what a quill shaft is? So it wasn't picking you, just pick it at random. Anybody else know what a quill shaft is? I should get a picture actually. I'll try and get one up for you. It's basically the drive shaft. Now, some components will come with the drive shaft integrally built. It doesn't come out. Some components, some CSUs, PCUs, modification ones might come a drive shaft that fits into the CSU or the sort of PCU, and when you fit that together onto the gearbox, that drive, that shaft spins your governor, your CSU, etc. Now these drive shafts, the quill shafts, they are they're not very big, easily forgotten. Okay, so if you go and fit your CSU and your PCU, and you go and start an engine, it's not working properly because you can't get control, you might have left the quill shaft out. They're also designed to snap. That should there be a problem with the CSU or PCU, that shaft will break. Rather break the shaft than the gearbox. Okay, so they're actually they're quite solid. They are got a wasted point where they will shear should there be a fault. Okay, easily forgotten to put in, and also helps for diagnostics. If it's not working, it could be the CSU, PCU has seized. Okay, as it's driving, it's better to break a small component than a big component like the gearbox on your engine. All right, so just be aware of these little cool drives. And any dials are located correctly. So don't force it on. Make sure the shaft's in there. It might be a fixed one or maybe a coil drive. Looks like the same thing. Rotate it on till it fits in. Then line up your holes for fitting the bolts to the flange, and then everything should be okay. Mechanical linkage on a piston engine should be adjusted so that the CSU control is on the maximum revs per minute stop when there's a slight clearance between the pilot's control lever and the forward end of the gate in which it closes. So just like fitting you'll cover this in module 15, we fit a gas turbine engine, we always fit the maximum stop on the engine first, and like here, we fit the maximum stop on the CSU as well, before we do the maximum stop on the control in the cockpit. Controls of the PCU of a turbine engine are interconnected with the high pressure fuel cock, okay, with one or more electrical contacts, again associated with the operation of the various propeller functions. Now, they may also be electrically or mechanically connected to the controls on the flight deck. It all depends on the aircraft type you're working on. Mechanical linkage is normally adjusted by locking the pulleys and levers and set positions, etc., using rigging pins. Rigging pins are, you will put these specialist pins in certain holes that when everything lines up properly, these pins will fit in with a positive feel. Not too hard, not too slack. They should just go in, just like using a feeler gauge, okay? Now, you might have to adjust the rigging to suit this up, and we'll cover that in module 15, but just be aware of these at the moment. Ideas procedure for certain controls for any particular aircraft must be obtained obviously from your maintenance manual. Now, setting up rigging is your standard practices on any manual for any aircraft, etc. Again, we'll cover this in module 15, but just be aware, if it doesn't fit, don't force it, follow procedures and adjust accordingly. And we see already typical location of your PCU and your CSU look pretty much the same. So there's the flange, it'll fit onto the gearbox, and then some sort of bolt. Just make sure when you fit it, it locates into the drive shaft properly. So testing after installation, after installing propeller, the engine must be ground on, as we saw already. Aircraft propeller installations will vary, so it depends on type. No set testing procedure would be satisfactory for all aircraft. So we have individual testing for individual types of aircraft. So imperative therefore that any particular installation should be tested in accordance with that particular maintenance manual. Okay. Just because you're authorised to ground on one type of aircraft doesn't mean say you're authorised to do it on another type, because there might be a few more different checks and controls to work as well. So for correct inspection of fluid de-icing systems, you should always refer to Sage enough back to your maintenance manual. You will become experienced in type specific, and you'll be able to do that pretty much straightforward. But again, always refer to your manual. So after each flight, when the anti-icing system was in operation, the blades should be cleaned with methylated spirits or in soapy water. So maybe worth highlighting that one. So how would you clean the blades? By using methylated spirits in soapy water. I need to put that in red, but if you highlight that in your books. Supply tank should be replenished. Yeah, it's been used. We need to top it back up again. Examine the overshoes for tips for adhesion failure. You might have to repair the adhesion like we saw yesterday. Again, check for carefully as they might lift in flight. If it's starting to come away, then obviously that's not good. If it keeps flying, potentially that could come off. Check for blisters and cuts. Yeah, any sort of damage that should be there. For correct inspection, again, refer to your manual, and longitudinal grooves on the shoes should be free from damage or any gummy deposits. Now, the fluid that comes out might mix a little bit, might get a bit contaminated, it might get a bit sort of gluey type effect, so it needs to be cleaned. Feed pipe, sling and ring, again, check for damage and cleanliness. Filters, pumps, check valve, removed and cleaned at intervals laid down by approved maintenance schedule. So every so many hours, even if it's working fine, like anything on an aircraft, you will take these components out and check them, inspect them, clean them, refit them, or replace them accordingly. And the system is not going to be in use. It's a good one to remember now. Not for a long period. What you'll do is you'll drain the system, refill it with 95% methylated spirits and 5% distilled water. Okay, so the aircraft maybe is in the hangar for a while for whatever reason, it's not going to be flying for a long time. Again, that'll be referred to in your manual for how long that is. Drain the whole system, 95% methylated spirits and 5% distilled water. So you can imagine when you come to use this again, you have to drain that and put the correct fluid back in. But if it's going to be for storage, 95% methylated spirits and 5% distilled water. Again, highlighting the books. Operate the system. Ensure the propeller is turned until the tank is empty. So basically clean the system out. Before commencing a flow test, the pump filter should also be cleaned. The check made on the vent valve and the tank for any obstruction. So making sure everything's clean basically. And then you fit an ammeter. Okay, now using it on your multimeter for your continuity resistance checks, you also need to get an ammeter. Now some multimeters can do both. Sometimes you have to get a separate meter, which is called an ammeter, which checks the current in the circuit. Okay, like I said, check the pump's rated value and the voltage supply at the correct level as well. So multimeter, if you've got a combined one, you can check the voltage and your current as well. Disconnect the delivery pipe near the sling ring and direct it into a calibrated container. So basically you're checking you've got the right voltage, you've got the right current, I'm going to check how much flow is coming out. So you're going to switch the pump on, note the fluid delivery rate, and also the reading on your ammeter. On multi-engine aircraft, all propellers should be checked simultaneously. Okay. The rate of the fluid should be within the limits specified in your manual by the manufacturer. And where you've got a rheostat control provided by varying the amount of flow, the flow should be checked at various settings, from minimum up to maximum. Okay, make sure it's working all over, because you might have a dodgy or maybe an unserviceable rheostat, which varies the amount of the power to the pump. Ampage required to operate the pump exceeds the rated value or delivery rate is too low. The sling and ring and pipes should be checked for obstruction. If there's a restriction there, that's going to put up the flow physically for the fluid and also restricting the pump. The pump's going to be struggling a little bit, so that's going to increase the current. If they are clear, then unfortunately it's a pump that could be defective. Again, follow your procedure in your books. Functional testing, yeah, functional testing system. Propeller should be painted with what's called commercial whitewash. Just like you do, I don't know if you do it there, but certainly here, if you've got any shops or houses that are getting built, they might just put whitewash in the windows so nobody can see in. Same sort of thing for propeller. It's a washable type solvent that goes on white. So when you put the functional system of your fluid delivery on, you will see where the fluid is actually going. Okay. And we'll also put a suitable dye in there added to the fluid, again up to the manual. Engine is running, the system is operating, the dye will stay in the whitewash, and that will let you see how the wash is distributing along the propeller. And it should be nice and even, hopefully. Uneven distribution may be caused by the slinger not being fitted correctly, feed pipes located, obstruction in the lines, etc. Again, you can go and check all that. So for electrical de-icing systems, we'll check the current inspection. You should always refer to the aircraft's maintenance manual as ever. Overshoes, boots, again, exam for splits, wrinkles, tears, discoloration, result of overheating, security of attachment, etc., and general condition. If it doesn't look right, it isn't right. Okay. If the heater element is exposed, well, that's obviously not good. A result of damage or if the rubber is tacky, swollen, or deteriorating, replace the overshoe in accordance with the procedure we spoke about yesterday. Cables, again, examined for cracking, fretting, and security. Imagine this is spinning round, so very easy for things to eventually wear off. Brushes and slip rings should be checked for wear, damage, clearance, and freedom of movement in the holders. In other words, everything on the propeller should be checked for being clean, secure, damage, etc., all in accordance with your manual. If in doubt, Okay. Now we've got some electrical checks and tests, obviously for the electrical side. Electrical checks, tests are necessary to ensure the functioning of a complete propeller de-icing system consists of those mentioned in the following polygraphs. So, information given, this is just a general nature. It will be more specific to each type of aircraft, but it's just a general background on the sort of thing it might come across. So first one to look at is a continuity soak resistance test. Again, exam-wise, you'll be asked a question maybe in continuity or resistance one, so we'll go through both of them. So continuity, you're basically checking you've got a closed circuit. Checks and measurement of the resistance of individual heater elements must be carried before installation. No point putting it on and then, oh, we've got to take it off again. Of a propeller, and describe inspection periods and following any repairs on overshoes. The resistance values must be within specified of the type of propeller. Okay. Installation resistance checks, again, are necessary to determine the breakdown between heater elements, the heater elements and blades, the brush gear and propeller spinner where appropriate, and insulation resistance between the brush gear and earth must also be checked. So that's for the insulation and resistance, okay? So the continuation one is just checking that the right ohms, and we're also checking that we've got a path to earth for the insulation check. During service, installation resistance of the heat elements may vary as a result of moisture absorption caused by atmospheric conditions, obviously. And numbers we've got to remember here are tested for must be carried out as prescribed instruction periods and ensure the resistance have not fallen below specified minimum in service values. Now, normally 2 to 4 mega ohms are typical. Okay, 2 to 4 mega ohms, worth highlighting there, are typical. It might vary slightly, but that's the average, so 2 to 4. So checking insulation. Okay. Insulation and resistance, some types of systems account also to be taken for specification. Also the type of cement. The cement can affect the insulation. The bonding, the blades, has that been on the values as well. Okay, so make sure you've used the right cement or glue. The limits relevant to cement specifications are usually presented in the form of graphs. Again, in your manual, you would check, okay, what type of glue was used? I should have this type of insulation. I should have this resistance value, depending on the glue that's been used. Then we do what's called a voltage drop proof check. Now that check required for some types of propeller. Again, you might have repaired the heater elements or the overshoes. And the leads from the heater elements are connected together and the high voltage. Typical values are almost 1400 to about 1000 volts, so 1300 and 600, or 960 volts AC, so almost 1400 volts DC to about 960 volts AC applied between the leads and the cable. The voltage should be maintained for not less than 1 minute, and the check made to ensure there's no breakdown of insulation resistance as well. So it should hold that voltage. If it starts to drop, then we've probably got a leak somewhere. Okay, not a physical leak, but obviously it can be shorting out somewhere. The voltages then must be increased gradually. So we'll start a little bit of voltage, then a bit more, then up to the specified amount in the book. Functional testing, yeah, on complete systems carried out periodically. Again, good old manual. For example, when new or overhauled propeller has been fitted, replacement or cyclic timer, heat element, brush pack, or repair no shoe, etc. And we'll check the heating by the heating currents applied to the blade and spinner at the correct periods, governed by the time and indicated by the ammeter, which forms part of the circuit in most installations. So again, you'll have your load indicator on your cockpit, which will be a current or ammeter anyway. So you've got an actual ammeter in the system, and be checking that as correct. Testing must be carried during a grounding, which will avoid overheating the elements. So again, only on for as long as applicable. After installing propeller, the engine must be ground run to check propeller operation. Propeller installations will vary considerably, again, all specific to your aircraft you're working on, and therefore, as normal, always carry out the test in accordance with your approved maintenance manual. Again, few tests, engine will normally be fully cowled. In other words, it'll have the doors around it. No point in having the doors off, because that will give different cooling effects and stuff. and should also be facing into wind before starting the engine run. If you've got a tailwind, it's going to cause a lot of strain on the engine, and it's also better to have the aircraft in wind anyway. It doesn't matter if it's a propeller aircraft or a jet engine, always put the aircraft into wind. Sometimes recommended the pitch change cylinder should be primed with oil before starting by operation of the feathering pump. Again, will depend on the type of aircraft you're working on, and it will state that in the procedures anyway. Safety precautions for any grounding should be followed. Again, there'll be somebody in the cockpit, you'll have safety persons outside, fire extinguishers, etc. Communications of some variety, okay, should be in there before the engine is started. Okay, proper PP and everything. So test and run include the following general requirements. The engines operate satisfactorily, and before using high power, the propeller should be exercised in the manner I've already spoke about. Again, that warms the oil up in the propeller and also gets rid of the air in the system. Okay, as it says there, warms oil, gets rid of the air. Make sure the pitch mechanism is working properly. And checks in the manual confirm satisfactory operation of the propeller, including constant speed operation, feathering, operation of the propeller pitch control range to its system, synchronization with other propellers on the aircraft as required. Operation of sorted warning and indicating systems should also be carried. Again, all specific to your aircraft type. Engine running time should be kept to a minimum, consistent with satisfactory completion on the check. So we don't need to run the engine for hours and hours. We get engine warm, we do the functional checks, we take a reading of everything, and then once we're happy, we shut the engine down. We don't need to keep the engine running as long as possible because that can overheat the engine. So again, careful watch on your engine temperatures, especially at EGT gauge, to avoid overheating. And same with turbine engines, change operating conditions should be carried out slowly to avoid rapid change in engine temperature and also help preserve the engine life. When all checks have been carried out, everyone's happy, and the thorough inspection propeller system is all good. Other checks, you'll be checking for security, make sure nothing's come off where it shouldn't have come off. Chaffing of pipes and cables, should be nothing touching where it should be touching. And usually thing is signs of leaks. Now, on a brand new propeller, you might get an initial leak till it beds in, but again, that's quite common, but certainly not excessive leaks. Turboprop aircraft. Turboprops are constant speed engines because they operate through the operation cycle at near 100% RPM. In other words, the engine is pretty much 100% thereabouts. It's the PCU that controls the rest. Told RPM constant, the fuel control, just the fuel flow in relation to the load. When idling, the RPM remains high, but the propeller pitch is reduced. It's almost flat. In other words, there's no high pitch on there, so it's not producing very little thrust. It's just cutting through the air, nice and easy, and therefore requires a minimum fuel flow. Mechanically controlled engines normally use two engine controls on the cockpit, so that's maybe worth noting just to make sure you're happy with that one. So mechanically controlled ones. Power lever, speed or condition lever. The power lever relates to the throttle of reciprocating the engine, but also gives the pilot control of the propeller during ground operation as well. Power lever relates to the throttle, okay. Affects the fuel flow, torque, and EGT, and usually has 4 positions: reverse, ground idle, flight idle, and maximum. We saw this already, but again, just make a note if you haven't done so already. Speed or condition lever primarily controls the engine RPM, hence by speed or condition, and sometimes it acts as a manual feather and also emergency cutoff lever as well. Condition lever usually has 3 positions, strange enough: emergency shut off, low RPM, and high RPM. Okay. If you look at the FADEC controlled engine, so the computer controlled one, there is a handling difference to look at. Condition lever no longer controls propeller and governor, as that task is there now calculated by good old FADEC, and depend on the position of the power lever, other aircraft system inputs, and flight phases. So test to ensure all members of the team have necessary training before you do any groundings, obviously. Authorization to carry that specific testing. Don't just jump in an aircraft and go and start it for a bit of a laugh. Consult all your appropriate documentation. Has all the job cards been signed for? Is everything ready to go? So aircraft, engine, propeller logbooks. Have you got fuel in the aircraft? That's always embarrassing if you don't. relevant maintenance manuals, service bulletins, etc., etc. Propeller checklist. You will have a checklist, pre-starts, post-starts, etc. Assemble, make sure you've got tools and equipment test ready you need as required. Make sure you've got communications, no problem going from an engine start, especially in bigger aircraft, you must have communications. Okay. Flight deck to ground and flight deck to air traffic control as well. Now, if you fit in a brand new engine as well as a propeller, it's also worth letting the air traffic know it's a brand new engine. They might actually send out the fire brigade as a precaution. We certainly do that with jet engines, and don't see why there'd be no difference with a brand new engine. Just in case there's an engine fire, yes, you might be able to put it out, but if it gets out of hand, then the big fire extinguisher should be there. So if it's not a brand new engine, it's just a propeller assembly, there's a good chance it should be okay. But if in doubt, get the fire brigade out. Okay, but always inform air traffic control. You also check air traffic control for temperature of the day, humidity of the day, pressure of the day, and that sort of thing as well. You need some information from air traffic. Make sure you've got also fire extinguishers, apart from the big ones there as well. Where any work other than engine starting requires HP cock to open, ensure that the booster pumps are off. At least 15 minutes have elapsed since it's shut down, or ensure that engine rotation has ceased and wait at least 5 minutes till the engine drains system clear. In other words, if the HP cock will put fuel to the burners of the engine, if you haven't waited at least 15 minutes or 5 minutes for the engine to drain, the chances are that fuel will go into the burners and it'll be that hot it could potentially ignite and you have a big engine fire. Okay, so you don't want to do that. If you let the booster pumps on, that will force that fuel through as well. Always parking to wind, position clear of other aircraft and buildings, because you've got to think of the downdraft from propeller. Ensure ground aircraft is clear of debris. All personnel not to be involved in the engine run should be at a safe distance. So you have safety people outside, make sure that people going past aren't anywhere near where you are. And at least 50 feet from the front of the aircraft, at least 50 feet. Bigger the propeller, I would say more distance, okay, but at least 50 feet, so worth noting that as well. And at least 150 feet from the back of the aircraft. Bad enough you're close to the front of the propeller, but the downwash from propeller to back could potentially blow off, especially at high performance runs. All personnel working in the vicinity of run engines are to wear air defenders and appropriate PPE. Okay. Make sure there's no loose anything about as well. Where checks involve an operator standing in the propeller slipstream, engine running must not exceed normal ground idle. So you might be in a quick leak check or something. Again, you don't want to be near that propeller at any point at all, but you might have to go to check underneath maybe an engine part, okay, or just an observation of something. But make sure you have contact with the pilot or the engineer and say, make sure your hands off and your propeller is at minimum speed. Very essential, no loose clothing. Don't go wearing ties, any fancy clothing in there, or normal PPE, make sure nothing's loose. Again, especially in the vicinity of running engine, if that catches on something, then you'll do it wrong once. Okay, prepare to observe detailed check. Chock the aircraft, wheels, so make sure you've got chocks at the wheels. Ensure you've got first aid firefighting equipment and all the crew are in position. And make sure the crew know what they're doing. Make sure they know what their task is for that day. And before you start, make sure you've got oil, make sure you've got fuel, make sure you've got hydraulic oil, all contents are ready. So the aircraft is ready to start. Ensure your logbook is available and note all relevant entries as required. Obtain outside air temperature and the QFE, your pressure of the day. Again, that's what was on about earlier. So you'll get that from air traffic control. Because remember, outside air temperature and pressure will change the performance of the engine. Okay, and also a hot day, cold day, etc. can change the performance of propeller. Ensure propeller is in the ground fine pitch for starting. If it's a turboprop aircraft and a free turbine, it doesn't matter. But for a fixed turbine and piston engine, yeah, make sure it's in the fine pitch. Yeah, double check it, keep mentioning it, but make sure your comms. Ensure communication, ground crew, flight deck, and so on. You will also have hand signals as well, communications, because sometimes you can't speak at the same time, you can have to give a hand signal. Again, you should all be composite with that. Starting run procedures are laid down as usual in your manual and must be referred to before commencing run. So you have a check sheet. Okay, so there might be two of you in the cockpit, depending on the size of the aircraft. You can check with each other. Ground running should be kept to a minimum. Throttles and controls operated slowly, smoothly to avoid rapid temperature rises and changes within the engine. Prolonged running, oil maximum conditions should be avoided, and in the event of a sudden increase in TGT or EGT, turbine gas temperature or exhaust gas temperature, abnormal instrument readings, stop the engine and investigate the cause. Okay. Again, when you become qualified ground runners, you've got react very, very quickly. Things 99% of the time are fine. It's when it goes wrong, it's down to you to react accordingly. Okay. Starting run procedure laid down in the usual manual. Leave the cowling closed except when doing a leak check and for making adjustments. Control locks must be on for all ground running to show that ground fine pitch is available to all propellers and that pitch coarsening is isolated on all the engines. So we can't actually go to, unless you need to actually check it, but normally you're just doing the normal engine run. If the engine has been running at high RPM before shutting down, allow the engine to cool for a short period and that will facilitate the cooling of the engine. TGT or EGT, turbine gas temperature or exhaust gas temperature must not exceed the alert for corrected figure if ambient conditions are below standard ISA sea level. Top pressure must be above the minimum acceptable figure. LP speed must be within the laid down limits, etc. High power running, as I said before, must be kept to minimum. And the main one to highlight here is after a power check, the engine must be run ground idle for at least 2 minutes, and that ensures adequate even cooling of the main core engine before shutdown. If you're at high RPM just suddenly shut down, yes, the engine will shut down, but you've got a very, very, very hot engine that potentially could actually go on fire. Okay, so we let it cool down, like any sort of engine to be honest, and then switch it down once all your indications, your cockpit gauges have come stable, RPMs come down, etc. Unless obviously if it's an emergency, you just shut it down straight away and get out of there. Engine thermal anti-icing must be off during engine running at takeoff throttle settings. Propeller checks, check all engine RPM settings with each propeller pitch settings again in accordance with your manual. Ensure manuals operate throughout all pitch range. Checking ground fine, to takeoff, to flight fine, feather, unfeather, thrust reverse as well, and your beta range. De-icing checks, yeah, make sure all the fluid system or the electrical de-icing system is working, again, according with the manual. Engine stop procedure, the following is just a general note. You will have specific stop procedures for most of it, but they are quite similar. Engine stopping, usually affected by shutting the fuel control valve or your HP shutter valve, your HP cock. It may be interconnected with your power lever or it may be a separate lever. And then allow the engine to stabilise at idle, that should read idle, sorry, I apologise there, I have to change that. Allow the engine to stabilise at least 3 minutes. Prolonged running oil maximum conditions should be avoided. Kind of a sudden increase in TGT, again, any unusual noise, stop the engine and investigate the cause. The count close, again, we said already for checking, making adjustments. Control locks, as I said before. If the engine's been on high RPM, again, allow cool down. Completion. On completion of all successful propeller ground starts test, complete all the work orders and tech log records as possible. Ensure return of all tools and test equipment. So before you sign any job card, you make sure your tools are away first. Reinstate the aircraft ready to fly. All is good. And then you will sign. So the last thing you do is you get your pen. That's the only tool you've got left is your pen, and sign your certificate of release to service. Okay. All right. Let's see how we're getting on there. Good. Okay, that's a good point to stop for break. Most of that there is basically follow the manual. A couple of parts there highlight the times for stopping, making sure safety and communications, etc. Not too bad. It's all quite common sense stuff, hopefully, guys. So as you go through the book, highlight bits you see appropriate. If in doubt, you follow the manual. Simple as that. So what we'll do there, we'll stop for about 20 minutes, and then we'll come back and we'll. This is a generalized one. You will have some more specific type troubleshooting problems or fault diagnostics to follow as per your aircraft type, and certainly the propellers you're working on. But this should hopefully give you a basic insight into what's going on. So again, just a general one. Always a pilot or mechanic to isolate potential propeller problems. And as you get used to working these type of aircraft you're working on, you will start to recognise certain faults that was happening at a certain time. Occasionally, though, things will happen that are not normal. And again, you might get special technical instructions sent out to check all the aircraft on the fleet. So this is just as you use a guide and just of a general nature. As I said, it will be more specific to the type of aircraft you work on. So they should not be used in lieu of any authorised, publicised procedures applicable to specific aircraft. These are just a training type generalisation of what potentially typical type fault diagnostics you might come across. Okay, so don't use these on your specific aircraft. So things we'll look at, basic sort of one is hunting and surging. Now, when we're hunting and surging, we're not going to kill an animal or something like that. We're just the sound effects or the propellers actually trying to find the air. It's going back and forward and that sort of thing. So we'll look at what hunting and surging is. Now, the official thing for hunting is a cyclic variation, engine speed above and below. So you get this sort of sort of sound effect with the change in the pitch. You'll hear it, and then we call that hunting. And we get that in gas turbine engines as well. The actual engine can hunt as well, but it's not getting control properly. It could be a fault with lots of things, and we're just going to look at a few generalizations. So surging characterised by a large decrease in engine speed, hence this sort of hum back and forward, followed by a return to set speed after 1 or 2 occurrences. And it might stay for that, it might settle down, it could go back and forth, but it could be a lot of things that's causing this. For propellers hunting, you get this sort of back and forward thing. Check for, you'll see this going through many diagnostics. The governor is at the top of the list on a lot of them. Is the governor controlling or is it not controlling? Okay, is it maybe not quite right? Fuel control, yeah, potentially a fuel issue within the actual engine itself. The synchrophaser or synchronizer system might not be working correctly. Okay, so again, you check them individually, isolate other systems first, but make sure you're getting the right procedure. So again, follow your procedure in your book. It will tell you which one to check first. Through experience, sometimes you actually go straight to the point. It might be a common fault that you know about after so many hours. Yes, it's going to be that one. Again, that comes to experience, but always follow your manuals if in doubt. If a propeller is surging, now cycle propeller to release trapped air from propeller. Again, when you exercise propeller when the engine's warm to release the air, if it suddenly surges into position, it could be because there's air in the system. There's nothing given resistance, so the propeller could potentially go to a course position very quickly. If surging reoccurs, most likely, again, here we go again, a faulty governor. And as I say, I keep saying this, you'll see a common trait is being the governor being at fault here. Hunting and or surging may also be caused by friction or binding within the governor control, the internal propeller corrosion, potentially, which causes propeller to react slower to the governor commands. Propeller and governor must be tested and at a propeller repair facility to isolate its fault. You can't, although we can do a basic governor test, we can't prove that the governor is working 100% correct. So if in doubt, you probably just go and replace the governor, send that one back to a test facility and check it. If you fit a new governor and it's still doing the same thing, then yes, the propeller is need to go back. So you might send the whole thing back as an assembly. Engine speed varies with flight altitude or airspeed. So the engine speed is increasing or decreasing as it goes up in altitude, down in altitude, or actually with forward momentum. So very small variances in engine speed are normal and are no cause for concern. So it's worth highlighting that one. Only very small variances. Okay, it's when you get exceptional differences. So maybe worth highlighting that one. Increasing engine speed while increasing airspeed. Well, what could potentially happen there? If you've got an increase in engine speed with an increase in airspeed, what's happening there to the propeller? Reference angle of attack. If that was a constant speed propeller, and we've got an increase in engine speed with an increase in airspeed, so what could potentially be happening there, do you think? Why would an engine go faster with an increase in forward speed. Go back to day one, angle of attack, that sort of thing. Yeah, the angle of attack will get decreased, which means the blade will be finer, which means it will spin the engine quicker. If it's a constant speed propeller, it should maintain the right angle appropriate to the speed. So again, the PCU can be full, or the governor, etc. Non-feathering propeller. Governor not increasing oil volume in propeller. Yeah. Engine transfer, bearing leakage excessive. Excessive friction in blade bearings. So you see there's quite a lot of things that could potentially be. Feathering or aerobatic propeller. Governor's not reducing oil volume. Again, governor, another faulty subject. Excessive friction in blade bearings, etc. A decrease in engine speed while increasing airspeed. So this time we've got a decrease in engine speed while increasing airspeed. So we're going, the aircraft's going faster, but we've got a decrease in engine speed. Well, if it's getting a decrease in engine speed, non-feathered propeller again. Governor pilot valve is stuck and excessively increasing oil volume. Feathering or aerobatic propeller potentially. Governor again, pilot valve is stuck, decreasing oil volume. Feather command engaged, propeller pitch control, and so on. Again, no feathering propeller. We've got governor pilot valve stuck, decreasing oil volume. Again, the governor. There's a common problem here, isn't there? You can start to see the trait of the governor. If in doubt, change the governor. Decreasing engine speed, well, decreasing airspeed. So this time we're decreasing in engine speed, but we're decreasing airspeed as well. So engine speed is decreasing while we're decreasing airspeed. Governor, oh, there we go again. Governor's at fault, not reducing oil volume and propeller. Excessive friction blade bearings, etc. Of a feathering aerobatic propeller, again, governor is not increasing oil. Engine transfer bearing leaking, and so on and so on. Excessive friction, again. Loss of propeller control, in other words, non-feathering propeller only. So loss of propeller control. Propeller goes to uncommanded low pitch or high RPM. Happening? Oh, governor, pilot valve sticking again. Again, we've got this common fault that potentially a lot of the problems are going towards the good old governor. Propeller goes to uncommanded high pitch, so a low RPM, in other words, a coarser pitch. Governor is at fault again. RPM increases with power and airspeed. Propeller RPM control has little or no effect. Excessive friction on blade bearings or pitch change mechanism, potentially. Internal oil leakage on the opposite side of the piston. So double acting one. Propeller goes to uncommanded high pitch. In other words, or feather position. We could have loss of propeller oil pressure, check. Yeah, check all that. Governor pressure relief valve for proper operation, could be that. Governor drive shaft for damage. The quill shaft, mentioned the quill shaft can shear off again, or it hasn't been fitted if you put a new one on. So again, governor potential fault. Adequate engine oil supply or inadequate engine oil supply. Engine transfer bearing seal leaking excessively. Start locks not engaging. Feather or aerobatic propellers only. Propeller goes to uncommanded low pitch, so a high RPM, so small angle of attack. So it means it goes faster, but it does it uncommanded, it does it on itself. Why is it doing that? Governor pilot valve sticking. RPM increases with power and airspeed. Propeller RPM again has little or no control. Excessive friction, bearings, change mechanism, etc. Broken feather spring, yeah. The feather spring's under a lot of pressure a lot of times. Sometimes the springs will eventually go. Just like in a car, your shock absorber has a spring and suspension has a shock absorber and a spring in it. If you hit a bump, the spring can break and it doesn't do its job properly. Well, this is like a spring in a single acting propeller. Yeah, that could break. Not common, but it can happen. RPM control is sluggish, so it's very slow to accelerate or decelerate. Oil pressure lost or low, feathering propellers only. In a single acting, if it's feathered propeller only, a single acting, if there's low oil pressure, it's just going to go to a coarser pitch. So there might be some sort of resistance there, but your RPM will be slow because your pitch of your blade is quite high, so it's trying to push through the air, so it's going to slow the engine down. Oil pressure lost or low. Check for proper function. Rigging propeller and governor control linkage. Check governor oil drain function. Propeller must be checked at a propeller repair facility for misadjustment of internal corrosion, again at blade bends. But oil pressure is low or lost. Think even simpler than that. Have you actually got oil in the system? You know, has it lost, so has it got a leak somewhere? Always think simple first. Don't go straight into the deepest problem. It could be something very, very simple. So feather slowly. Propeller must be checked at a proper repair facility for misadjustment, internal corrosion, pitch change mechanism, etc. Failure to unfeather. Check proper function and rigging of control linkage. Could be broken or it might be set properly. Again, check the governor function. Also check oil leakage at engine transfer casing, bearing even. Propeller must be checked at a proper repair facility. If it fails to feather, if you go down the list, you can see this in order. The 13.4s and 0.1s, these are subsection, subsection, subsection. So as long as you follow it in the correct order, and that seems okay, but tend to the last part. If in doubt, what's going to happen? You're going to send it back to the repair facility. Start locks, anti-feather latches, fail to latch and shut down. Again, on your propellers only. So the start locks failed to latch. Propeller was feathered prior to shutdown. Shutdown occurred at high RPM with propeller control at the low pitch stop. Excessive engine transfer bearing oil leakage again. Excessive governor pump leakage. Lots of things. Broken start locks, yeah, could be something simple as that. It said there 14.1, 14.2 above may be solved by restarting the engine, placing propeller control in the proper shutdown position, and then shutting the engine down. So it might be an emergency shutdown. We've sorted the problem, start the engine back up, and can reset it if need be. Other ones, problems that should be referred to an authorised repair facility. So fix what you can in accordance with the instructions. If you've done everything by the book and it's still not fixed, send it back to manufacturer. Okay, vibration. Any vibration which can be described as appearing sudden or accompanied by unexplained grease or oil leakage should be investigated immediately before the next flight. Vibration problems due to propeller system imbalance are normally felt through the engine RPM range, but intensive vibration obviously gets worse with the increased RPM. Vibration problems that occur in narrow RPM range are a symptom of resonance, which is potentially harmful to the propeller, because the propeller, if the engine RPM has a certain resonance and matches the propeller resonance, that can amplify it and potentially be disastrous results. Okay. Avoid operation again until authorised repair station can check your propeller. Post vibration check, control surfaces, the cowl flaps, exhaust system, landing gear doors, etc. for excessive play, which also could cause vibration, giving you a false sense to the propeller. The propeller could be working fine, but it's actually something unrelated to that system. Again, you would check all that as a priority. Isolation of engine controls and lines, so you might have to isolate certain parts just to make sure there's nothing loose, nothing where it shouldn't be. It could be the engine mounting. The rubber bushes that hold the engines in, they could be wearing out, maybe a bolt sheared or something. Uneven or over lubrication of the propeller as well. Lots of things you can check. Again, all you have to do is follow the procedure. Correct engine propeller flange mating, yeah. Maybe put a new propeller on and you're getting a bit of vibration, but again, maybe the front cone isn't matching the flange, so you have to shim up the back cone and that sort of thing. Minor adjustment required. Remember your 1/8 of an inch and your 1/16 of an inch measurements. Blade track, yeah. Maybe be a little damage to the blade itself. Check the tracking. Has the tracking out? Blade angles must be within tolerance between blades and on the propeller as a whole. Again, obviously repair to propeller overall manual for your blade check procedure. Spinner for cracks, incorrect installation or wobble. So again, actually visually watching the engine starts up, do you see the spinner sort of shaking a bit? Maybe it's a bit loose, or maybe something's not quite right. Again, you see anything that looks abnormal, shut the engine down and go and investigate. Carry out static balance. But if you're going to static balance, you have to take it off, put it on the two knife edges we spoke about yesterday. And your airfoil profile identical between blades or overhaul. We should make sure they are the same. Again, that's going back to a repair facility for that type of thing. Propeller installation. Remove and reinstall propeller 180 degrees from original position. Sometimes something simple can do that. Even we do it on jet engines. We can take the spinner cap off, move it 180 degrees, put it back on, and sometimes if it's a minor bit of vibration, that can actually cure the fault. Just one of those things. And the same for the propeller. Take it off, put it 180 degrees, put it back on again, try it again, and sometimes that can actually sort it as well. It's a nice, well, depends what type of engine you've got. If it's a flange, a splined, a small engine, a big engine, obviously. But sometimes just moving that is a nice, easy way to do before ripping parts out. You don't need to rip parts out. Hub damage or cracking. Like we saw the inspections yesterday, there's a crack on the hub. Yeah, that could cause a lot of problems. And grease oil leakage, well, that should become apparent. You always get a little bit of leakage. It's quite normal with these ones, but excessive amounts that's more than normal, it's definitely worth investigating. Bends or blade deformation. Why is the blade bent? Could be mishandling. It could be over, maybe the pilot overstressed the engine, didn't tell you, that sort of thing. Or just a weakness in the blade. Note there, dynamic balancing is recommended after installing or performing maintenance on propeller. Exactly as we spoke about yesterday. Yes, you do your static balance on propeller in a nice environment inside a hangar or a workshop somewhere, but we can only do dynamic balancing once it's actually fit to assembly. But normally an optional task, it may be required by the engine or airframe manufacturer to make certain the propeller engine combination is balanced properly before operation. Okay. Again, that'll be more specific to the engine and the aircraft type. Again, you just follow procedures. Always refer to your engine or airframe manuals. I'll give you an example on the turbine engines. When we were fitting a new compressor to a new engine, a turbine, we would have to count how many splines around the shaft on the compressor, and that would measure up the heavy point on the turbine and the heavy point on the compressor, and they would twist together and would set a line up at a certain point. That was just specific to that type of gas turbine engine. And you might have something similar for your propellers as well. Propeller overspeed. After reported propeller overspeed, hopefully the pilot will have told you what percentage was and how long it was an overspeed for. Hopefully not very long. It could be something similar as a gauge error. Maybe it didn't. Maybe it was indicating faster, but it didn't sound fast. The pilot said, "Well, the engine didn't sound any different. My tachometer was telling me I was going faster than normal." It could simply be a sensor error. So don't just go replacing the propeller or changing a component or governor when it's actually could just be a gauge. However, it could be a low pitch stop adjustment. Governor maximum RPM is set too high. Yeah, the governor, it's stopping it there. Loss of oil pressure, oil starvation, or good old governor failure again. Governor pilot valve jammed to supply high pressure only. So again, for your constant speed one. Oil leaking past piston. Yeah, because in the piston in your cylinder, as the piston's going back and forward, there's a seal that stops oil going outside of it. She's only going to a certain point. If oil's getting past there, then yes, that can cause problems as well. Under speed condition, after reported propeller under speed condition, so let's just say, for example, pilots put the power up, but it's only getting a certain RPM. Again, it'll be experience of the pilot or even yourself as an engineer on the ground that it sounds okay, but it's not indicating properly. It could be a gauge error again, or it could be again excessive transfer of bearing oil leakage, feathering oil, etc. Again, the governor oil pressure could be incorrect. Also, oil passages could be clogged. Yes, it's blocking the actual system, so it's not allowing the change mechanism to move it to a higher pitch. Okay, so actually a finer pitch, should say. Oil leaking past the piston, again, causing a propeller lock. Oil and grease leakage. As I say, you will get a little bit of grease leakage until things warm up, seals start, especially in cold days. Grease leakage, which can be described excessive and appearing suddenly, especially when accompanied by vibration, should be investigated immediately and again before flight. You will always get a little bit of oil leakage, always get a bit of grease, but you will get used to the engine type, the propeller type of what is normal. Okay. A new propeller may leak slightly during the first several hours of operation. Yeah, until everything beds in, everything seats down, wears into itself, and then it should go away or certainly reduce substantially. If it continues to be excessive, then often something's not right. Leakage may be caused by seating of the seals and O-rings. Again, you might put a seal on, you can maybe trap the seal as you put it on to wherever the component is, not quite sealed properly. Take it off. You might find it's crushed the seal or nipped the seal or something like that. Okay. As it says there, leakage can cause seating of O-rings during assembly. Such leakage should cease within the first 10 hours of operation. So again, it'll leak for a little bit, but if you want to highlight that one, it should, in theory, within the first 10 hours of operation. Might be worth highlighting those ones. After reported oil grease leak check, damaged blade shank. Again, anything's got a seal in it, it's going to leak potentially. Damaged hub seal at hub parting line. Damaged engine transfer oil engine hub flange. Anything's got a seal on the drive shaft, on the flange, potentially has a potential to leak. And again, a cracked hub. Yeah, that'd be a very good idea. Cracked hub is often indicated by grease emerging from what is a seemingly solid surface, especially in the blade arm area. Okay, that's just a basic insight. Don't use these procedures on your actual aircraft. It's just a generic, general potential of what you could actually see or happen in an aircraft. Common things is if you put a brand new engine on, a brand new propeller assembly, you are potentially going to get leaks. If you remember, roughly up to about 10 hours, it should go away. If it doesn't look right, it isn't right. Go and investigate it. Shut the engine down, see what the problem is. Is it just simply you haven't let the engine warm up, exercise the propeller enough to get rid of air for hunting and surging, that sort of thing? Or is there oil in the system? You've got to top the oil system up. Some propellers have a little gauge on the side. In the Jetstream aircraft we've got an oil filler sight on the side of the hub, and for the aircraft engine as well. Is everything secure? If in doubt, take it back off. Has it been fitted properly? Have your cones been adjusted properly? A lot of things. So again, when you are assembling propeller assemblies and fit them, take your time, don't rush the job. Yes, the company will tell you, I need my jet now. Sometimes you get a lot of pressure from up above the management saying, right, we need to get this aircraft down now. Why is my aircraft not ready? You only go as fast as you are safe. The vehicle. Safety is
our vehicle
primarily the first and utmost thing you must carry out. Okay. So yes, you'll get positive pressure. We need to get the engine ready, or we need to get the propeller ready, but you follow procedure. You maintain your safety at all times. What could potentially happen? You hurt yourself. That's bad enough. What could really happen is something goes seriously wrong in the aircraft, it takes off, and then a lot more people unfortunately hurt. Aircraft can be replaced. People can't be. Safe, safe, safe. Okay, that's what we shout on aircraft. Always be safe. Okay, any questions on diagnostics? That's just a very, very basic insight on some of the typical ones you might come across. Again, as I said before, the real ones you will work on your aircraft will be more specific, but you will get through experience. You'll start, even just by listening to the engine, that doesn't sound right, or it's doing that, we'll go and check this. But again, as long as you follow procedure, you sign for the jobs you're doing, that makes sure you've covered your job 100%. And if something abnormal happens, then you can highlight to the manufacturer and they will issue a special technical instruction and maybe go and check all engines. Something, a component might have been made in by a manufacturing process that's not maybe up to scratch. It could be a faulty drive shaft, it could be a faulty casing, and so they're going to be manufactured. Things like that do happen in the aircraft world, and indeed cars as well. Keep going with cars, being an ex-car mechanic. So yeah, if you find something abnormal, highlight it, put it up the chain of command to your supervisors, and if need be, it will go to the manufacturer and they'll suggest an improvement or modification and that sort of thing. Okay, so that's just a basic troubleshooting. I'll just check which ones I've highlighted that hopefully I've mentioned there to make a note of. So yeah, the ones with hunting and surging, yeah, potential, the governor, synchronizer, sync phaser systems, decreasing engine speed, increasing airspeed, look at those ones. Everything else is pretty straightforward. As I mentioned, some of the faults there was a common component. Was the governor was at fault? You won't strip the governor down, but you will If you suspect the governor is faulty, you will replace the governor. Okay, and that'll go back to manufacturer proper testing. Okay. That's not too bad there. Okay, look, how are we doing for time? Not too bad. Any questions, guys, there on that part? Again, have a read through them. You know, take your time, have a read through them. Don't worry too much about the main bits. You will start recognising parts and pieces there. Again, I'll put a couple of questions up, I'm sure. Let's go back through the revision. So the last chapter I've got, which is storage, preservation, and packaging, that sort of thing. Not a lot there. It's basically how we look after the propellers when we take them off, when we put them away, and they're not going to be used for a long time as well. Okay, so I think what we'll do before we start that one, because that'll take us right up to lunchtime at the latest. So yeah, why not? Let's go for a break again. That's just what I have to just have almost 10 past there. Come back about 20 minutes, and then it'll be the last part of the theory, and then it'll be just be revision, revision, revision. Okay, so hopefully I've got the questions. I hope you guys have got the answers. But don't worry, when we do the PowerPoint revision one, I'll probably start with the book first. We'll go through the book and then put the PowerPoint questions and answers on there as well. Okay. So yeah, go back for another break, guys. Come back. Yeah, what time's that? Come back at past, and we'll start on chapter 5. It won't take long at all, that one. Okay. See you in a bit.
Hello.
Hello. Who was that?
It was me, sir. Yeah,
Yeah.
Paras money. It is showing tea break in my display, sir.
It is, yes. We're having another tea break. Did you go away for too long?
Okay, I was also busy for getting some hot water.
All right.
Okay, see you, sir.
Yeah, we're back. Come back at past. Okay.
Okay, sir.
Thank you. You think, well, everything's enclosed, why is it going to corrode inside? Well, especially with piston engines, they will corrode inside because the air in the pistons. And likewise, if there's no fuel moving around, fuel can actually corrode the engines, and propellers, the oil will drain down a little bit, again, open up potential areas to corrosion, and externally as well. So propellers that are used for any length of time should, where practical, be ground run periodically, so every so many days, or some sort of anti-corrosive treatment applied to them, externally and or internally as applicable, to help prevent deterioration. Remember, prevention is better than cure. To prevent or to protect, the treatment applied to propeller depends again on how long it's going to be out of service for, and if it's installed in an aircraft, it can be exercised or not. So basically, if it's a good working engine, we can run it every so many days. If it's not going to be working because maybe you've got electrical fault with the actual aircraft that stops us working the propeller system or mechanical system, then we need to do something extra on top of it. The aircraft itself could be in the hangar getting a repair for something totally unrelated to the propeller assembly. In general, for instance, with propeller assembly, excuse me there, preservation is normally required. Okay, so again, it's just a general guide. You will follow your own specific aircraft manual. And we describe it as being off the wing, so the propeller is actually not fitted to the aircraft. And look at what's called short-term and long-term off the wing. Then you've got on the wing, again, short-term and long-term. So there's two terminologies, propeller off the wing and on the wing. Again, excuse me, will depend what sort of preservation we actually carry out. So general propeller preservation, easy for me to say. Okay, if we look at these ones here, I've highlighted, you've got in this definitions table here, you've got F and G, so short-term storage, that's classified up to 3 months. It's worth highlighting these in your museum book. Again, that should be in your pages somewhere. I might not have it. I think it's written down. Yeah, it's written down in your book.
151.
Yeah, page 51, yeah. Just highlight it there. Short-term, 3 months. Long-term is more than 3 months, okay? Then look at categories 1 and 2. Category 1, equipment which in service operates on mineral or mineral-based oil. Again, so if you know what type of oil system. And category 2, equipment which in service operates on synthetic oil. Now, synthetic oil is more like to be your gas turbine, your turboprop engines. Okay, the gas turbine propellant. Your mineral oil, mineral-based oils, they tend to be your piston engine ones. Okay, but if you're aware of those two and those two. There are various different sections as well, in service, out of service, inhibit, off-wing, not installed in aircraft and so on, but those are some of the most common ones. Short-term storage, long-term storage, and whether it's mineral-based oil or synthetic-based oil will determine what we actually need to do to carry out. As well as everything else that's in that table, definitions. Be aware of those two main ones. Manuals, associated data requirements, yeah, always refer should meet the appropriate component maintenance manual for all the information you require. The approved maintenance cycles, any repair instructions, overhaul instructions, assembly and disassembly instructions as applicable, and also test instructions. And the same for special and necessary tools, and obviously what we're speaking about now is just storage and preservation materials. Okay. All the approved materials should be used. Don't make it up yourself. Don't go and just grab something off the street. For propeller assemblies, lubricating oil, normally mineral, stroke synthetic, piston, turbo engines. Inhibiting oil, some sort of corrosion preventative. We used to call a thing called OM11, which we used to put in the fuel system on the aircraft I used to work on. Again, you have something similar for yours. Soft film surface compound, a corrosion preventive, some sort of grease type stuff. Detergent or soap, low alkaline, so it's not. It can clean components ready for preservation, and also if you put preservation compounds in there to clean it off prior to use. And a low detergent type soap, like an alkaline base, won't be corrosive to the metal substances as well. Wrapping, polythene, tape, waterproof, all that good stuff. Especially if the aircraft's getting left outside for whatever reason. Paper wrapping, what I mean by paper, not just normal paper, but grease-proof wrapping. And white spirit to help cleaning solvents and greases off. prior to storage, because we want to apply some compounds and grease to the propeller assemblies and etc. But at the same point, we need to be able to clean it off as well. So we want to clean it first, apply the correct compound, and also before use, we'll re-clean it. So in the context of storage specification, the term storage will be regarded as covering any equipment that has been placed in stores. Simple as forward. Equipment can be new or overhauled equipment, which has not been yet installed since manufacture or overhauled, in fact, or equipment that you've actually removed from the aircraft itself. That's what I mean by putting into storage. Okay, so categories: equipment out of service, including installed in aircraft or out of service, equipment in storage, equipment spending some time in storage, sometimes installed, etc. Now, calendar periods, as we saw there, the 3 months sort of mark. Calendar periods and specifications usually commence from the date of manufacture of new equipment, or once having been overhauled from the date of the last overhaul. Okay, so they will be given a life as such. Once having been installed for the calendar period purposes, any subsequent time spent in storage is usually regarded as install time and not stored time. Completion of the maximum permitted flying hours of any equipment overrides any calendar period. So yes, they might be able to keep that apart in storage for on the aircraft for so long, but the flying hours is also the least lifing point. So if the flying hours exceed or get to the point where it's only, let's for example, 1,000 flying hours, just a random figure, and that's before, let's say, the 3 month point, whatever, we will have to take that equipment off and go and service it. Out of service equipment, if installed, store propeller assemblies should be inspected frequently and to detect any signs of deterioration, corrosion, leakage, etc. And again, carry out any rectification as required. Obviously, don't just leave it, it needs to be done immediately, otherwise it will just get worse. Equipment should be exercised, so in other words, moving the propellers, and inhibited in accordance with your maintenance manual for that propeller. Overhaul periods, again, propeller and any extra items attached to it, normally overhauled every 5 years, so it's worth noting that one. Or as the approved overhaul period of a propeller to be stored. So normally every 5 years. That may be 5 calendar year storage time or 5 years combined storage and installed on wing calendar time. Now remember, if the flying hours beat that, or they do a lot more flying compared to that, it will be removed before the 5 year point anyway. But if everything's okay, and it's not been getting used a lot, but it comes to the 5 year point, then it needs to be taken out, even though it's working fine. But if the flying hours have been done a lot of flying in that aircraft, and that is before the 5 year point, then obviously it will be taken out before that. Spinners, the cap on the front of the hub, normally overhauled on condition. Okay, it's usually just a good old inspection, make sure there's no damage. There's no lifetime on that one. It can be on as long as possible, as long as it needs to be, unless it also gets damaged or whatever. But anything to do with engines, propellers will have a lifetime because they go through stresses. Protective treatment, once applied, protective treatment shall be restored if you remove it or damage. So you need to be able to inspect something, you clean it off, then you'll restore that protective equipment. So off-wing, short-term storage. Now equipment required for storage for less than 3 months. This is off the wing, so it's not actually fit to the aircraft. Examine the propeller for damage, corrosion prior to going in the store. You'd probably do it before you take it off, but certainly somebody else might have taken it off and you've been tasked with putting it in storage. So again, you would check it. Close attention to the blades, the spinner and the backplate. All defects must be remedied before the propeller is accepted to store. So you don't just put it in store and put an annotation in, it's broken. You would repair, where possible anyway, as best as possible. So off-wing, again, equipment stored for less than 3 months. Caution, do not use a hose pipe. Avoid excessive washing at blade roots. Okay, if you try and do a hand wash down there and that sort of thing, because if you put a lot of hose pipes, the pressure from the water can get into behind components within the assembly, which if you can't get it out, it's going to cause corrosion. So it's just going to defeat the object of it. So preferably wash the blades by hand, use a clean lengthy cloth and a low alkaline soap type detergent. If necessary, clean metallic surfaces at the blade roots using clean cloth as before and the cleaning fluid. Treat all steel surfaces at the blade root with a corrosive preventive compound with steel Well, if steel is exposed to elements, it's going to corrode, it's going to rust. Preservation compounds such as special jellies, oils, greases, or aerosol sprays must not be applied to the blade surface of composite propeller blades. So composite propeller blades are not metal. Okay, if you apply jellies and compounds, that will deteriorate the compound and make the propeller unserviceable. It's no use at all. So make sure steel blades only, that's fine, but or aluminium blades should say, but any composite type material, no greases or oils on there at all. Ensure the blade tip protectors are fitted, some sort of rubber tight caps that will go in there, something getting damaged. Wrap the blades in a polythene and secure with tape. Also make sure everything's dry beforehand. Add on to that one, clean the hub associated parts using a clean lint-free cloth and cleaning liquid. And do not let the clean agent to enter the blade root joint either. Any liquids we're trying to keep away from the joint, so always hand wash and minimal amount of liquid. Coat all metal surfaces on the hub with a clean propeller system oil. And do not coat surfaces of the de-icing slip ring. Because if you put oil in there in the slip ring, that's where the metal contacts for the carbon brushes are. Again, that could cause problems when you reassemble it. Protect the de-icing slip ring with a plastic slipping cover. There should be one designated for it. No special preservation is required. Basically, keep it clean, keep it covered. Polythene sheet. Clean the spinner using a clean lint-free cloth as usual and a low alkaline soap or detergent. And again, wrap the spinner in grease resisting paper and secure with tape. Loose items will be treated in the following way. Unused seals which are older than 10 years since the date of vulcanization is when they're formed, in other words, or manufacturing, you just bin them. Now the best way to do it is don't just throw them in the bin, because you might say, oh, why is that in the bin? Open them, cut the seal, that way nobody can use them. They might look okay, but the material breaks down after 10 years, so do not use a seal. If you get a seal from stores to fit onto a job you're doing, check the batch date. If it's older than 10 years, cut it, put it in the bin. Don't even try and use it. Unused seals are suitably packaged for storage, so you might have seals that are within use, that's fine. You may have a seal kit to go with the propeller ready to use, that's fine, but make sure the seals are in date. Any open damaged parts, don't bother with them, just put them in the bin. Okay, don't seal them back up again. All discarded items should be replaced by new unused items. Again, loose bolts, washers with clean system oil is appropriate. That helps prevent corrosion. Put them in some sort of container box. Make sure they're not open to elements. All discarded items again should be new. Treat loose bolts. Again, oil is appropriate, and happy days. Any loose parts, again, in a nice rigid box, make sure to stop from rattling about and be safe with them. Caution, do not apply tape to the beta tubes or the blades. If you apply tape, the residue from the glue can stick to the rods and that can cause problems with the rods going back and forward. Again, the tape on the propeller as well. It can potentially take it off, it can absorb into the paintwork on the aluminium ones, but certainly, definitely not on the composite type ones. That's just going to be in the blades. Long-term storage, so long-term storage more than 3 months. Again, examine the propeller as we've done before. Give again to the blades, the spinner, exactly as we've done before. Any defects, the same as we've done before. Fix beforehand. Assemble propellers in long-term storage or off the wing must be periodically exercised and re-inhibited in accordance with your manufacturers at 6 monthly intervals. So it's worth noting that one. So more than 3 months, every 6 months, the assemblies must be removed, okay, and re-inhibited. The first exercise in re-inhibiting must take place before 6 months, have elapsed since placing the propeller in store. Okay, so it's going to be stored after 3 months. It's probably inhibited as it came off the aircraft if you're lucky, but before 6 months is up, you must exercise it first, and then every 6 months after that, you must do the same again. Prepare assembled propellers for long-term storage as for short-term storage did before. Again, any loose items, exactly as we did before, short-term. So off-wing, propeller assembly off-wing, exercise inhibiting. Care must be taken using blade, the bats, the ones we showed you in the pictures, for moving the blades to exercise single-acting propellers as it could overload the operating pins. So again, make sure you've got the right amount of people there. If it's a 3-bladed propeller, use 3 people with the 3 bats. Use a spring compressor where possible. Single acting exercise propeller through its full range. Again, that'll show you how to do that. And on completion of exercise, ensure that the blades are in the fully feather position, because if you leave them locked in the fine position, that leaves the spring compressed, which potentially won't act properly before. Now, we've had that in our place. We've had an old engine, the back of the hangar, it was left in the fine position, and we could not get it to release. It took absolutely ages to try and release this spring. Eventually it went, through a bit of determination, but it took a while. Okay, so never leave them with the springs compressed. It's quite dangerous as well. Do not allow piston to hold on the pitch latch stops, twist and store, just like I mentioned there, like we had in our place. Adequate exercising ensures stores life of the bearings, assembled seal rings, and limits the adhesion of the damaged seals to working surfaces. Sometimes if they dry out, seals can stick and they just won't go, and that's what happened with our very old engine. It had been used for many years, and we managed to dig it out and get it using for training aid. Inhibiting ensures that protective oil film is maintained on internal surfaces. Yeah, so by moving it back and forward, it makes sure the inhibiting oil goes to the right places. And do not at any time load the propeller blade or blades with the weight of the propeller. Okay, so in other words, don't support the propeller by the tips of the propeller on some sort of storage stand. Use a hub as the center point. The propeller should not be supported by themselves. So again, appropriate stand. We've got stands where we actually take the propeller assembly off, we turn it 90 degrees and lay it horizontal onto a support stand. So there's no weight at all on the actual propeller blades, it's all on the hub. The dummy flange that we put it onto. Propeller will normally be separate from the spinner and the beta tubes, and it's important that the propeller is mounted again via the hub assembly, so as just mentioned there. Movable protective covers. On the hub boss near the blade root, mark a line, mark using a soft pencil or wax crayon. Don't use a permanent marker because that will damage the metal. Make a similar matching line, mark on the blade near the blade root and in line with the line mark already made in the hub. Now, the reason we're putting a line there, we can tell when we've exercised it and stuff like that as well. Preferred number of operators to move the blades is 1 for each blade, makes it far easier. And the minimum requirement is 1 operator for each of 2 opposite blades. So if you've got a 4-blade propeller, you'd have 1 on one side and then 1 on the other one, sort of thing. But triple 1, ideally 3 if possible, but you can't move them with 2. Use appropriate bats or paddles or spring compressor, whichever is applicable. Move all the blades simultaneously. Don't try and move one at a time because you'll just bend the blade. And put to the full reverse position. And it says pour approximately 500 to 600 cubic centimeters of clean system or inhibiting oil, depending what your manual says, as applicable, slowly into the bore of the piston cylinder assembly. Again, use the blade parts or spring compressors to move the blade slowly through the range. Now, it is under a lot of pressure, so be very, very careful with these ones. Oscillate the blades backwards and forwards 4 or 5 times, okay, ensuring that complete movement of the full range of the blades has been carried out. I like that one. Lighting propellers, finally move the blades towards the original position indicated by the pencil wax crayon match you had before. It's a requirement that the marks do not line up and position the blades at least 25 to 50 millimeters away from the original mark position. Now the reason is for that, if you've exercised the propeller, fine, but if you put back the same position, then it's going to be where it was before. So by exercising and leaving it away from this position, that's a new position, so it stops potential corrosion happening there in the same place as before. That's why you mark it and move it, as it says there, 25 to 50 millimeters away from the original mark position. So when you next 6 months you come to do it, you'll make a new position. On second-hand propellers, the blades must be returned to the fair position. The reason being, you've got that spring pressure, so you can't leave the spring compression, so you must put it to the full position. So you're pretty much stuck that way. But on double-acting one, we can move the piston wherever we want. Okay, put a different position each time you do that exercising and inhibiting off the wing. On completion of exercising, always remove your pencil wax crayon line matched by wiping with a clean, good old lint-free cloth and a suitable cleaning compound. Okay. Then we go to on-wing, so actually fitted to the aircraft. Again, equipment is required for store for back to less than 3 months now. Ideally, on-wing storage should be undercover inside a hangar where possible, or enclosed building. As normal, examine propeller for damage, corrosion prior to storage. Again, give close attention to the blades, spinner, and backplate as we saw before. All defects must be remedied before the propeller is stored. Do not use a hose pipe, I've mentioned already, because water can go into places where it shouldn't be going, especially near the blade roots. We don't want to go near the blade roots because we can see some horrendous corrosion. And as always, wash the blades by hand, just like we did before, off the wing. Preservation compounds, again, as mentioned before, jellies, oils, do not put them on composite blades. And again, make sure your tips are fitted. Clean the spinner, again, good old lint-free cloth and detergent. Again, I mentioned before, under the hangar, an additional requirement for short-term storage is coat all exposed metal surfaces with an approved corrosion preventive compounded jelly. Now remember though, if it's a propeller, it's a composite one, don't put it anywhere near there, but semi-exposed metals, some sort of protective grease. But clean it first, then apply the compound. Wrap the spinner with a wrapping moldable waxed grease resisting tech material and secure with tape. Wrap the blades in polythene wrap material, just helps stop the air getting onto them, and again, tape them up. Clean all accessible external surfaces of auxiliary items and components as we've done before, and again, fit appropriate shipping covers as required, or blanks. Now, as you're doing this to propeller, you'll be doing protection to the engine at the same time as well. On wing, if you're exercising then stop propeller, that eliminates the need for inhibiting, and it keeps the things nice and easy. Whilst on the wing. Adequate exercise ensures storage life of the bearings, assemble seal rings, and limits the adhesion of the dynamic seals that we saw before to the working surface. In other words, we keep it using. If you leave something for too long, it will stop working, it will be stuck due to moisture and potential no lubrication. A protective oil film having an inhibit effect will be maintained on all the internal surfaces by the exercising the blades. Now, the propeller needs only be exercised every 3 months when it's stored under cover. So every 3 months, exercise the blades, that'll be fine. Propeller stored on the wing in the open air of an airfield, parking lot, etc., or often serviceway will, strange enough, need more frequently, and that's down to the manual for your type. But generally, though, once every month. Okay, so inside every 3 months, outside at least once a month. A propeller which has been out of service for between 6 and 12 months without being exercised must be subject to all normal installation and functional checks specified by the manufacturer and as applicable prior to entering or reservicing. Okay, so between 6 and 12 months, and it hasn't been exercised for whatever reason, maybe forgotten or whatever has been missed, you've got to go through all the full. Now, hopefully it'll be okay though. Propeller out of service. Again, on the wing, for 12 months or more without being exercised, must be stripped, inspected, re-greased prior to re-entering service, okay? So you might have got away with it the first time, but oh, we've got to do that, but it's within the 6 to 12 month period. Let's carry out normal functional checks as prior. However, if you go past the 12-month point for whatever reason, you should never get to that point, you'll have to ship it down and basically do an overhaul, okay? Make sure it's okay, no corrosion. Exercise inhibiting, do not run the fairing pump more than 2 minutes. That's a good one to highlight here. So don't run the fairing pump for more than 2 minutes in any 30 minutes. Okay, so no more than 4 times in an hour, if that makes sense. If you're doing 30 minutes, that's more than ample time to do your run. But make sure you do not run it more than 2 minutes in any 30-minute operation. Okay, good one to highlight there. Exercise on wing consists of a functional operation of a propeller 3 times, minimum 3 times, through its full operating range. So in other words, you start the engine and you're doing a full operation from min to course to min, min to course to min, at least 3 times. Okay, exercises shall be carried out statically in accordance with the normal installation functional acceptance checks for re-entering service. Acceptance checks for entering re-service will be permitted by propeller manufacturer and ensures that means for replenishment of the oil tank is provided as necessary. Okay, so the 3 times to its full operation range, acceptance checks for any time, again permitted by the propeller manufacturer. And the change that one's the same as the previous one. Okay, optional to the static operation is the appropriate engine may be run. So your static one is exercising propellers at least 3 times, but not run the engine. But obviously, if you run the engine, we can exercise the propeller. Okay, as permitted by the manufacturer. After all that done, quality control. We need to have some control when this was carried out, who done it, etc., what was used. All equipment, so serial numbers of the propeller assembly, the engine, the date, the times, etc. Batch numbers are to be accurately recorded. And at all times, the correct approved materials have been used and processes have been carried out to the requirements of the specification given in the appropriate publication. Any defects discovered during pre-storage examinations must always be remedied before they go into storage. No point in putting a broken thing in store and then take out when somebody said, why is this broken? Okay, so always remedy it before it goes into storage. All outstanding work numbers and whatever else needs to be done have to be actioned before equipment can be accepted into store. Correct equipment labelling and traceability documentation to attach and located with the propeller and all its associated loose equipment. SB is your service bulletins. Okay. Any shelf life and deterioration services requiring attention during the scheduled storage is to be recorded and actioned as appropriate. So in other words, you need to record everything you do on the pre-storage serviceability. Make sure you've got a recording of all the serial numbers, all the part numbers, any information, because that assembly can be taken as one. You might have the seals with it, or the bolts, etc. You might even make a contents list that goes with it. Give as much information, because it might not be yourselves that go and put that propeller back on. It can be a completely new team member or members for that appropriate. Time between overhaul and calendar life stated, excuse me, an appropriate manufacturer services bulletin must, subject to any finalised limitation, must be strictly observed. A service bulletin might come out and you've put the propeller assembly in storage and something's come out, something's happened to another propeller of the same type and it needs to be checked. So although this is in storage, it needs to come back out and checked in accordance with service bulletin. Okay, and just to check if there's maybe a potential fault there. So again, make sure you keep an eye on that. A record of propeller exercises should be recorded in the propeller logbook. Yeah, that needs to be noted. So especially the 3-month point on wing, etc. All right, and that, gentlemen, is about it. Yeah, that is pretty much it. That is the end.